we are fortunate to have Dr. Krocak here with us today. So Kenzie is a research scientist at the University of Oklahoma Center for Risk and Crisis Management, and also the Cooperative Institute for Mesoscale Meteorological Studies as part of the NWS Storm Prediction Center there. She earned a BS in meteorology from Iowa State in 2015, and then went to OU where she earned a master's and PhD in meteorology in 2017 and 2020. Now, what's important and one of the serendipitous events is, as Randall said about the anniversary, we also dedicated the memorial to that event today. So it's auspicious that she's going to be talking about how we use information and during hazardous weather events to decide what to do. So it's a pleasure to have her. I'm also been asked to mention to those of you listening that Kenzie is a cat mom. And so you can ask her questions about that also. So Dr. Krocak, thank you again for joining us. And I will be coordinating the question and answer at the end. So please, as Randall said, put questions in the question and answer or in the chat, and we'll make sure we cover them. So thank you all very much and enjoy the talk.
All right, thank you for that introduction. I am going to get my screen sharing going here. And hopefully you can see just the slide. Is that working?
I believe you should be able to now.
All right, let me do that one more time just to be sure.
All right, you're good to go.
Thank you. All right. So thanks again for that introduction. And yeah, very serendipitous to have it on the anniversary of the F5 tornado. Had I known that, I probably would have used examples from that event, but alas, we will talk about an event that actually happened earlier this year. And yes, I am a cat mom, and you may or may not get to see a picture of them later on in this presentation. I admit I don't know that I could do a presentation without incorporating some type of cat picture. So like John said, I will be talking about understanding what we do during severe weather events, and mostly couched with data from the Severe Weather and Society survey. And so I have to thank my many collaborators at the OU Center for Risk and Crisis Management, including Joe Rittberger, Sean Ernst, Carol Silva, Hank Jenkins-Smith, and many, many more that I can't list out there. So the first thing I really want to talk about is how the current severe weather information system is structured. So we're going to go through sort of how an event is communicated from a few days out down to minutes before the event occurs. So if we start that 2 to 8 days before the event, there's a lot of information that's already being shared generally. I'm going to be sharing information from the March 25th, 2021 event, which is an event that I was paying particular attention to just because it was one of the first severe weather events of this season. And it occurred in the southeastern United States, which actually has a number of communication and response challenges that are really unique to the area. So in this upper left-hand corner here, you'll see what is the Storm Prediction Center's convective outlook. And what it shows is the risk for severe weather increasing as you go from these green colors to yellow and then orange. And then I've also included a few screenshots of some tweets from broadcast meteorologists in the area. So James Spann was talking about that convective outlook here in the right picture. And then in the left-hand picture, he's actually showing significant tornado parameter, STP, which is basically just talking about tornado potential. And then we have another meteorologist down in the southeast, again, talking about those similar colors and levels with the yellow slight risk and the orange enhanced risk. Again, talking about a severe weather event a few days out. Then as we get to the day of the event or a few hours before tornadoes occur, we sometimes see a severe weather or tornado watch issued. So that's what this top picture is. with the red counties highlighted. And this watch was a particularly dangerous situation, or PDS tornado watch. And what this means is that it's a really high-end watch that they're expecting numerous dangerous tornadoes to occur. Then in this lower graphic, this was a screenshot from the local National Weather Service. And again, you can see sort of these different colors indicating severity or the number of events that might happen. And then they're also starting to talk about timing. So when this event is going to occur. We've done quite a bit of work that has shown that timing is actually really important, but that we're not as good at forecasting it or communicating it. Then as you get to minutes before the event occurs, you start to see these radar screenshots being shown on social media and on television. And if you're familiar with severe weather, you probably know that this is a radar image of a supercell, and the tornado is likely occurring at the end of the hook echo. Then you might be able to see this really thin red line. That's the tornado warning. So after you get the watch, if a tornado is in your area, then you'll be issued a warning, which means you have generally somewhere between 5 and 15 minutes before the tornado occurs at your location. And then of course, it leads to damage to homes and other structures. So we go from days out before the event down to the event occurring, and there's a lot of information. And this is just a few of the screen grabs that I could find. There's an insane amount of information that you can find if you go digging for it. Even if you don't go digging for it, here in Oklahoma City, you'll get everything from the local broadcast meteorologist talking about it for days and days, all the way up to the billboards. The digital billboards in our area will say, severe weather occurring today, be prepared. So there's just a lot of information in this system and a lot of things to digest as a user. And so what we are really interested in is understanding, how this information flows and how people use it. And one of the things we come across a lot is this idea that a perfect forecast, if we can just have a better forecast, it'll lead to a perfect response or a better response. And I'm sure many of you probably know that that is not always the case. In fact, it's often very rarely the case. So as a meteorologist, my training is in meteorology. We're really good at predicting the weather, but unfortunately, those perfect forecasts do not mean that we will get a perfect response. And that really has to do with the fact that we're forecasting for humans. We're not robots. We're not computers who take in information and immediately know what the best decision is. And more than that, we live in a very complex world with a lot of different decisions to make. So the example that I like to talk about a lot is, imagine that you're a parent and you have your children down at school or in daycare or in some other building, 3 blocks away, and you get a tornado warning, and is your immediate response to go and shelter? Like, maybe, but maybe not. Maybe your immediate response is to go and make sure your kids are okay, or to go and make sure your elderly neighbor or a parent or someone else, or, if it were me, again, I'm a cat mom, I'd be really worried about my cats, so we don't live in this vacuum where we just take in a piece of information and immediately make a single decision. There are a lot of different pressure points or other things that we have to think about. So the decision-making process is very complex. And this schematic here that I have is very, very boiled down, but it focuses on the parts of the process that our work really looks into. So first, people have to receive a forecast or a warning. They can't make decisions based on it if they don't receive the information in the first place, the trigger to make them make that decision. Then they have to understand the forecast. They can receive a warning, but if they don't know what a warning means, then they probably aren't going to make, quote unquote, the right decision. So in our work, we tend to study reception, understanding, and then response to information. And like I said, we're really interested in the pressure points or, things that can get in the way of making those decisions. So to do that, we field the Severe Weather and Society survey every year. And it's a survey of the US public that measures, like I said, perception, understanding, and response to severe weather forecasts in the United States. We generally include two types of questions. The first type is what we call repeat questions. And they measure these core concepts like reception, understanding, response. And we do that, we repeat these questions every year to try to get some longitudinal data, understanding how these core concepts are changing each year, or if they're changing at all. This also helps us to build a baseline so we know when we change the system, how that system change impacts reception, for example. So we can start to measure how these changes are impacting people's decision making. The second type of question are new questions that measure interesting topics or projects we really want to look into. And a really good example of that is in the 2020 survey, we actually included questions about COVID-19 because we knew that that would probably have an impact on people's response actions. So in the southeastern United States, there are a lot of public storm shelters, for example, that people tend to go to when there's a warning around. With COVID-19, we were interested to know, one, how these public shelters were functioning, if they were even open, and two, if people felt safe using them. Because now they have to balance the risk of a tornado and the risk of getting COVID-19. So there's these competing risks, and how do they make a decision with those two risks? And then generally we have 2,000 to 3,000 respondents each year. So we started this survey in 2017. So we have somewhere around 8,000 to 10,000 survey respondents total. So now let's go back to that March 25th event that I introduced. And we're just going to break down the event step by step and talk about some of the things that we can study with this survey data. So if we go to 2 or more days before the event, again, we see these severe weather convective outlooks from the Storm Prediction Center. In the gray areas on this map, those are areas that are not under a risk. Then we go to light green, which is general thunder. And then the darker green is the first level of the severe weather forecast. So it's a marginal risk. Then we go to a slight risk in yellow and an enhanced risk in orange. So the labels for those 5 different levels are listed here, with marginal again being that first level of risk, and then high being the 5th level and the highest level. So it goes marginal, slight, enhanced, moderate, and high. So we wanted to know how people interpret this ordering of the levels and whether or not the current ordering is intuitive to people. So is it easy to understand and is it easy to use to make decisions? So this experiment comes from some master's work from Sean Ernst at the University of Oklahoma. And what he did was he asked people to order these 5 words from 1 to 5, with 1 being the lowest and 5 being the highest level. And what he found is that for the first word, most people, about half of our respondents, wanted that first word to be slight. Then the second word, most people wanted to be marginal. The third word, moderate, was the most popular. Then enhanced for the 4th word. And then high was by far and away the most popular for the 5th level, or the highest level. So what that means is that this ordering, for most people, they actually preferred marginal and slight to be flip-flopped, and also enhanced and moderate to be flip-flopped. Now, some of this makes sense. Moderate, I think, to a lot of people is usually the middle level, and slight might seem less intense than marginal. So this wasn't necessarily surprising to us, but there are reasons that that original ordering was chosen. So we asked, well, what can we do about this lack of intuitiveness? What can we do about people maybe thinking that this isn't very intuitive? So we ran another experiment the next year where we said, on a scale from 0 to 100, how concerned would you be if you were to get this forecast? And we gave people a different combination of the forecast labels. So we put marginal with a number, level 1, and we said slight level 2, etc. We also gave people just the level numbers. So we eliminated the words completely. And what we found is that even when you combine the words with the level numbers, people still wanted to flip-flop marginal, slight, and they wanted to flip-flop enhanced and moderate. So that wasn't any more intuitive than the original labels. However, people did order the levels 1 through 5 pretty consistently, which again, maybe isn't surprising. So what this really showed us is that the current words that are used are not very intuitive, and people actually anchor to those words. Even when you put numbers next to them, they really like to look at the words, not the numbers. So we're working closely with the Storm Prediction Center to understand what the next steps are and what the best way to move forward is. Then if we look at the day of the event, when we have this severe weather watch, the particularly dangerous situation watch, we wanted to understand how people use that watch information, what they do in response to it, and if it is effective at getting people to start making decisions before the warning timescale. So we asked a couple different questions. The first one, we gave them the definition of a watch. So this alert is issued when tornadoes are possible. It does not mean that they will occur. It only means that they're possible. And we said, is this a watch, a warning, or are you not sure? And we found that most respondents were able to identify it as a watch, even with just the definition shown. And this is important because it maybe isn't completely fair to just give them the definition and ask them to provide the answer, right? Think about it. If you are told you are under a tornado watch, usually you're given a little bit more context. Usually they'll say like it's the entire state of Oklahoma, for example, or they'll say, be prepared, a tornado warning could come later. So just giving people the written definition of a watch and asking them what it is potentially a pretty challenging question. And even so, most of our respondents were able to correctly identify it as a watch. So in addition to that question, we also asked them, if you are given a tornado watch, how much time do you have before the tornado arrives? And again, over half of our respondents were able to correctly identify that a watch is somewhere between 1 and 24 hours long before a tornado will occur. We did have some respondents say that you had less than 1 hour, which isn't necessarily wrong. Sometimes tornadoes can occur in the first hour of a watch. What's a little bit more concerning, though, is that there was about 10 to 15% of our, 15%-ish of our respondents say that you had 1 to 3 days before the tornado occurs. And that's concerning because that is much longer than any watch would be. But it's maybe a little bit under, people could have been confusing a tornado watch with a tropical cyclone watch, which does tend to last a few days. So it's understandable how this could happen, but it's still a little bit concerning because if they think they have 1 to 3 days to respond, and then all of a sudden they have 3 hours, that could obviously be pretty problematic. So in addition to understanding whether or not people know what a watch is and how long it will last, we also wanted to know what people would do when they get a watch. And so a recent experiment was conducted where we actually gave respondents an open answer reply so they could type in whatever they want. And I actually had to sit there and read like 3,000 of these responses. And let me tell you, some of them can be really, really interesting. But what we did was we gave them a scenario where it was 9 a.m. the next morning, and you were given information that a tornado would occur in the next 4 to 8 hours. And then we said, okay, what would you do? Well, what we found is that 15% of people said that they did not know what they would do or that they would do nothing. And while this is a little bit concerning, what's maybe more concerning or more interesting is that 25% of people said that they would go to shelter. So I don't know about you guys, but when I grew up in Minnesota and we got a tornado watch and we knew that we could get a tornado warning soon, my mom said, well, okay, put the kids down in the basement, give them a sleeping bag and a movie and maybe some Chex Mix, call it a day. It really wasn't a bad time to go down to the basement. And that's pretty much where we sheltered. So we essentially sat there and sheltered for the entirety of the tornado watch. Not a big deal. I now live in Oklahoma where we don't have basements. And so our tornado shelters it's really a hole in the garage with the slidey thing that goes over it. And it gets really hot down there. I have sheltered once in it and it was not comfortable. And I would certainly not sit there for 4 to 8 hours. Not only was I uncomfortable, but so were these two. So I promised you a cat picture. This is Mowgli in the front and Diego in the back. And they are very sweet and very loving until you try to put them in their cat carrier, and then they are not happy. So the idea of trying to shelter with cats is kind of a no-no. And you only shelter when you really have to. So the idea that 25% of people are just going to go shelter when they, are going to spend 8 hours in their shelter before the tornado comes is probably not realistic. And so it probably indicates that they also don't necessarily know what to do during a tornado watch. So this is a potential area where we could start to explain what the best things to do during a watch is. Maybe we want them to monitor the weather. Maybe we want them to double check that their shelter is clean. There are no spiders and down there that you don't want to be involved with. Maybe we want them to check on their plans for this evening. Maybe we want them to consider canceling the outdoor baseball game, things like that. So giving people some idea of what they can do when they get a tornado watch might be really helpful. So then if we move on from day of the event to the warning time frame. So now you've got this warning. You have 10 to 15 minutes max until the tornado occurs. We have a number of different experiments where we talk about warnings and how people receive warnings, how they understand them, and then what they do. So the first thing we ask is, where do you get your warning? How do you get your warning when the time comes? We spend a lot of time looking at these graphs about where people get warnings because it's changing quite a bit in recent years. And so it's pretty interesting actually to see things like television still being the most prominent way that people get warning information, but also see things like the internet in this teal color and then social media in the pink at the end, increasing pretty dramatically over the last few years. However, like I said, television is still the #1 way that people get their warning information. What I find to be really interesting, though, is this graphic from some undergraduate students that I'm working with. They wanted to look at warning sources based on people's age. And so they separated our respondents out by their generation. And what you can see is that the older generations are on the left, and in the television column especially, you see this really dramatic drop off with age. So 74% of the silent generation respondents are still saying that they use TV to get their warning information. Compare that to only 39% of Gen Z. I mean, it's pretty remarkable to see that drop off. And then you'll see the younger generations using things like the internet, social media, word of mouth, and even sirens more than older generations. So we're still trying to understand why this may be the case. I mean, we know why. We know partially why, right? I mean, younger folks use a lot of social media and a lot of internet. But the sirens one in particular is interesting. And maybe we need to start talking about, again, how sirens are not meant to be heard inside. So if you are in your home or in an apartment, you're likely not going to hear that siren. But I just think that the drop-off, especially in television, is really interesting and really important for our broadcast meteorology partners. Then after we ask them, how do you get the warning? And we wanted to know how confident they were that they would get this warning at different times of the day. So we asked people a number of questions, like, how confident are you that you would get a warning when you're with a small group of friends, when you're working, when you're in your car, when you're sleeping? And what we found is that when you vary the time of day that people are given a warning, their confidence in receiving that warning can also vary pretty dramatically. So if you watch the green line here, it's really flat, really consistent, and pretty high. So pretty high confidence, that's pretty consistent all the way until about 10 p.m. Then you see that green line start to drop off pretty dramatically until about midnight, and then it hits a minimum between 1 and 4 a.m. before it starts increasing again into the morning. So what this is essentially showing is that people know that it's really hard to get tornado warnings overnight. I am trained as a meteorologist. My husband is also trained as a meteorologist. And so we have a weather radio that goes off anytime that a tornado warning occurs. And it's great. We always know when a tornado warning is issued, but every time it goes off at 2 a.m., we both sit there and we're like, should we just go unplug it? Like, this is kind of annoying. And we're meteorologists. So imagine people who aren't as in tune to the weather as we are getting those alerts overnight. It's frustrating and it's not always relevant for your area. So you begin to understand, one, why people don't always have those systems because you get woken up in the middle of the night. And two, just how difficult it is to receive a warning if you don't have a system like a weather radio. It's going to sound like a very loud siren in your living room at 2 a.m. And then the cats scatter. Like it's just a whole mess, as you can imagine. So these are some of the questions that we're really interested in asking at the warning timescale. We've asked some questions about response as well, and people generally know that they need to shelter when they get a warning. The problem is first getting the warning overnight sometimes, and also making sure that you are prepared enough to immediately shelter, that you've made some of those plans prior to the warning scale so that you don't have to be doing all of your decision making in the 4, 5, 6, 10 minutes before the tornado occurs. So that's kind of where I want to stop for now and just say that with this severe weather and society survey, our general goals are collect high quality data, useful data about how people use severe weather information, particularly how they use the current system, such that if and when we change the system, we can understand if those changes were good or if they were not so good. So we tend to adapt the survey as the products from the National Weather Service change and as people change. Again, talking about things like the COVID-19 pandemic and other risks that people have to deal with, because it's not always just about the weather. And then for future endeavors, we are starting to collect data about other hazards, including tropical cyclones and hurricanes. And we just last month fielded our first survey in the winter weather domain. So all of our folks up north who experience winter weather far more often than tornadoes, for example, we are starting to collect data about how they use winter weather forecasts as well. And potentially in the future, we might expand into fire weather or earthquakes. So with that, I think I'll stop and take questions. So thanks again for being here. I appreciate it.